All right, section 8-5, powers of products and quotients. I talked to you a little bit about the other day, powers of products, where we're working with something to the base, raised to the m power, raised to another power. That's the powers of raising a power to a power. So we're going to be looking at problems like that and dealing with quotients to some power. So we're going to all talk about that here in a little bit. Basically, the thing is you have to distribute it to every single thing in the quotient. So let's look at this. Power of a product. Power of a product, the expression the quantity 3x to the fourth power is an example of power of a product. What this means is you have 3x 4 times. 3x times 3x times 3x times 3x. So you have to take 3 times 3 times 3 times 3, which is 81. X times x times x times x. Remember, all these are first powers, so you add them together, which gives you x to the fourth. So what they did was come up with this nice little property that says if you have more than one thing in there that's being multiplied, that n has to go to every single thing in your quantity. So this now becomes a to the nth power, b to the nth power. Let's look at example 1. It says simplify a negative 4x to the third power. So that 3 has to go on everything. It has to go on the negative 4. It also has to go on the x. So it's a negative 4 to the third power, x to the, 1 times 3 is obviously 3. What's a negative 4 to the third power? Make sure you put that into parentheses. Negative 4 to the third power, you know it's going to be negative. 4 times 4 is 16. Times 4 is 64. X to the third power. And that's your answer. Let's look at quiz yourself 1. We have 3 times x times y to the fourth power. Once again, the 4 has to go onto the 3, onto the x, onto the y. Every single base gets this fourth power. So 3 to the fourth, x to the fourth, because 1 times 4 is 4. Y to the 1 times 4 is also 4. Well, what's 3 to the fourth power? 3 times 3 is 9, times 3 is 27, times 3 is 81, x to the fourth, y to the fourth. Example 2, same thing. Okay, once again, that 3 has to go on the negative 5. It has to go on the x squared. It goes on the y cubed. It goes on z to the first power. So, it's negative 5 to the third power. I always get in the habit of putting parentheses around my exponents because whenever you have a negative, you need to make sure that that's a positive number. Okay? X squared to the third power, 2 times 3 is 6. Y to the third raised to the third, 3 times 3 is 9. Z to the 1 raised to the third, 1 times 3 is 3. A negative 5 cubed. 5 times 5 is 25. Times 5 is 125. I have an odd number of negatives, so this is negative. X to the 6th, y to the 9th, z to the 3rd. Power of a quotient property. Power of a quotient property for all non-zero a and b, and for all n. Okay, I got a quotient raised to the n power. That n goes on the numerator, and it also goes on the denominator. Okay, no matter how many bases are up here, that n has to go on all of those things in the numerator and the denominator. Very important property that you need to know. Example 3 says, write 3/4 to the 5th power as a simple fraction. Okay? That 5 has to go on the 3. It also has to go on the 4. So it's 3 to the 5th divided by 4 to the 5th. 3 to the 5th, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, divided by 4 times 4 is 16, times 4 is 64, times 4 is 256, times 4 is 1024. There is my simple fraction. Moving on to quiz yourself 2. Rewrite 11 times 2 divided by m to the 6th power as a simple fraction. Well, we're going to do the 2 divided by m to the 6th power first, and then we're going to multiply it times 11. Okay? So, 2 to the 6th, because the 6 has to go on the 2, it also has to go on the m. 2 to the 6th divided by m to the 1 to the 6th is 1 times 6 is 6. And then we're going to take this times 11. Well, this just looks like multiplying fractions. First thing we got to do is we got to find out what 2 to the 6th is. So 2 times 6, or 2 to the 6th power is going to be 64 times 11 64 times 11 is 704 all over. M to the 6th times 1 is just m to the 6th. Remember, as long as we have positive exponents, we are fine. Only when we have negative exponents do we have to worry about moving those somewhere. That's all I have for you today. We'll see you tomorrow.